Alright, let's take a look at a couple of examples for some of the asymptotes and see what we can come up with here. So let's take a look at one on the left first, the f of x function, 2x squared, and my second power didn't come out real nice there, over x squared minus 1. So again, let's look at a couple situations here. First one is, one thing you should always try and do is simplify by factoring and see if anything else can reduce. On top, it's a monomial, so there's only one term, so we're going to leave that one alone. On the bottom, however, that's one of our special types of factoring, difference of two squares, so that's going to be x plus 1 and x minus 1. Now, sometimes this factoring is good because it's going to help cancel something and make it smaller and easier to work with. Other times, like this, it's just going to help us find zeros potentially. So, on this one, our first thing is, let's find our vertical asymptotes. And if you remember back, we said we're going to let our zeros of our denominator, in other words our domain, become our vertical asymptotes. So there's another reason why factoring in this case isn't bad. We could have also just said x squared minus 1 equals 0 and went with that. But since we took the time to factor, let's do it that way. So we'll just say x plus 1 equals 0, x minus 1 equals 0, and solve them. So subtract 1, I get x equals negative 1. Add 1, I get x equals 1. So those two values, 1 to the left, vertical line, 1 to the right is 0, vertical line, those are my two vertical asymptotes. Now as far as the horizontal asymptotes for this one, again we go back and we take a look at the two biggest exponents. In this case, they're both 2's. Now, when they were both equal, we said our situation was going to call for lead coefficients. In this case, 2 over 1, or 2. So since they're equal to each other, all we're going to do is say y equals our top lead coefficient over our bottom lead coefficient, which just reduces to 2. So y equals 2 is going to be our horizontal asymptote. Now, we weren't really asked to do anything with the picture on this one, but we'll just throw something together here real quick as a sketch. All it's going to tell us is, up on top, our vertical asymptotes were at negative 1 and 1, so I would go 1 to the left and do my vertical asymptote, 1 to the right, do my vertical asymptote, and then my other one would be my horizontal asymptote. I would go up to where 1, 2 is, and I would draw my horizontal asymptote there. Now the purpose of this section, or these two problems, is just to find where they're at. Nothing else to do with the graphing. We'll deal with that in just a little bit. Alright, over to our g of x problem. Let's do the same thing with this one if we can. So we're going to look and simplify first, and this one works out pretty nice. I'm going to get an x plus 2 and an x minus 1. And if I factor the bottom, I'm also going to get an x plus 2 and an x minus 3. So that's my factored form. Now the one thing that happens with this is I've got a common factor on top and bottom. So my x plus 2 on top and bottom cross off, so I'm actually just left with x minus 1 and x minus 3. So let's work with our vertical asymptote first. So our vertical asymptote, we said, take our bottom. Well, the only thing that's left is x minus 3. So we're going to do x minus 3 equals 0 and set 3 added to each side, and I get that. So my only vertical asymptote is going to be x equals 3. We will talk about that cancellation in just a little bit here, but for the time being we're just going to leave it at, yep, something cancel. Now our horizontal asymptote, again we're going to go back and we're going to take a look at our two biggest exponents, in this case a 2 and a 2, So we're right back where we finished off on that last one, where all we're looking at is lead coefficient, because the rule says they're equal to each other. So 1 over 1 is just going to be 1. So y equals 1 is going to be my horizontal asymptote. So for this one, our quick sketch, y equals 1, oops, let me change colors up here, y equals 1 is going to be my horizontal asymptote, and my vertical asymptote, the only one I got was 3. So I would go out here to where x equals 3, and there we go. Now the situation up here where we ended up with that cancellation, once we actually get to the part where we're going to draw our pictures, the cancellation there came from an x plus 2. So I would actually set x plus 2 equal to 0 and solve it. X equals negative 2. So that means out here at negative 2, when my picture's up here or down here, that's going to lead to a hole in the graph wherever x equals negative 2 happens to be when we actually get to the part of drawing our picture. So that's something that we'll look forward to later on. But as far as just finding the asymptotes and what they mean to our picture in the drawing anyway, that's all it is. So follow the rules, step your way through it, and you'll find what you need to find. So that's it for finding those. So our next step is going to actually be doing the work of doing an entire graph, and that's going to be next.